The Dark Ages were not empty. That long stretch of time before the first stars was supposed to be a cold, black nothing, a universe with the lights not yet switched on. Then the James Webb Space Telescope turned toward the oldest corner of creation, and something looked back. Its name is MOMSI 14, a galaxy already burning 280 million years after the Big Bang, 13.5 billion years ago, and by every model we had, it should not be there. This is the story of the point of light that is quietly rewriting the beginning of everything. To understand why a single point of light has so many astronomers rattled, you have to understand what the Dark Ages actually were, and why anyone expected them to be dark in the first place. The universe was supposed to be empty here. That is the quiet assumption sitting underneath everything. Picture the cosmos a few 100,000 years after the Big Bang. It is a fog, but not a cold one. It is a blinding fog of light, a thick soup of hydrogen and helium, so crowded with loose particles that a beam of light cannot travel in a straight line before it slams into something and scatters. The whole universe glows. Then it cools. The particles settle. The soup clears, and that ancient glow drains away into the dark. Once it fades, there is nothing left to replace it. No stars, no galaxies. Nothing has caught fire yet. For a long stretch of time, the entire cosmos is a cold, black ocean of gas, with not a single point of light anywhere inside it. Astronomers did not choose the name Dark Ages to sound dramatic. They chose it because, as far as anyone could tell, it was literally true. And then, somewhere in that darkness, the first lights come on. The first stars. The first clumps of gas, heavy enough to collapse under their own weight and ignite. It is the first sunrise in the history of everything. That flip from a dark universe to a lit one is the single hardest thing in all of astronomy to actually see, because it happened so long ago and so far away that the light has been stretched and dimmed almost to nothing by the time it reaches us. And it is exactly the place a telescope just caught something it was never supposed to find. It helps to understand how hard the previous generation tried and how little it managed to catch. For decades, the sharpest eye we had on the early universe was the Hubble Space Telescope, with a mirror just under 2.4 meters across, a little under 8 feet. Hubble was a marvel, but it had a ceiling. To see the earliest galaxies, a bigger mirror is not enough. You also have to see in infrared, because the expansion of the universe drags visible light down into infrared wavelengths across those enormous distances. Hubble could only reach so far into that range. By the time Webb launched, with a gold-coated mirror over 6.5 meters wide, around 21 feet, tuned specifically for infrared, Hubble had confirmed exactly one galaxy from the first 500 million years of cosmic history. 1. A single object called GNZ11, found back in 2016, hinting that these early galaxies might be more common and brighter than the theory allowed. But it was only a hint, a single point at the edge of the possible. Everything else out there was a candidate, a maybe, a smudge waiting for a better instrument to confirm it or throw it out. So when astronomers finally aimed Webb at this era, they carried a confident prediction with them, built on decades of work and the best models anyone had. The first galaxies would be small, faint and rare, a few dim sparks scattered thin across an enormous dark room. Keep that picture in mind, a few dim sparks in the dark, because what Webb actually found turned it inside out. In the spring of 2025, a team led by an astronomer named Rohan Naidu at MIT was combing through Webb's images, hunting for candidates. They were running a survey with a name that tells you exactly how skeptical they were going in. They called it Mirage or Miracle. The whole point was to sort the distant smudges into two piles: the real galaxies and the tricks of dust, light, and noise. The mirages. And in this line of work, most of the time, you bet on the mirage. A single fuzzy red dot at the limit of your instrument has 100 ordinary ways to lie to you. One object kept refusing to behave. It sat in a well-studied patch of sky called the cosmos field. in the direction of the faint constellation sextans. And in the first images, below a certain wavelength of infrared light, it simply was not there at all. That sounds like a flaw. It is actually a fingerprint. When a galaxy is so far away that the expansion of the universe has stretched its light to an extreme degree, the shortest wavelengths get erased. Absorbed by the hydrogen, the light passed through on its long journey to us. The light just stops below a hard line, like a wall. Astronomers call that wall a Lyman break, and it is one of the most reliable distance signatures we have. The farther away the object, the higher up the spectrum that wall sits. This object's wall was sitting almost impossibly high, one of the sharpest, highest breaks anyone had ever seen. A photograph can suggest a distance like that. It cannot prove it. So the team did the one thing that could settle it. They pointed Webb back at the object and took a spectrum. A spectrum splits incoming light into its individual colors, the way a prism splits sunlight into a rainbow. Buried inside those colors are lines, sharp, bright and dark bands that work like a barcode for the object. That barcode tells you exactly how far the light has been stretched, and stretching means distance, and distance means age. There is no faking a spectrum. It is the difference between thinking you saw something and knowing it. The number came back at 14.44. If you do not speak astronomer, that sounds like nothing. Here is what it means. Redshift measures how much the universe has expanded since light left its source. As space itself stretches, it pulls the light's waves longer, shifting them toward the red end of the spectrum and then past it into the infrared. The bigger the number, the longer the light has traveled, and the further into the past you are looking. A redshift of 14.44 means we are seeing MOMZ14, as it was just 280 million years after the Big Bang. The previous record holder, another Webb discovery, sat at a redshift of 14.32, a galaxy from about 290 million years after the beginning. MOMZ14 edged past it by roughly 10 million years. In a universe 13.8 billion years old, 10 million years is a rounding error. But out at that frontier, every step closer to the start is ground we were never supposed to be able to reach. This was now, officially, the most distant object known to humanity, the oldest thing any human being has ever laid eyes on. And that distance was almost the boring part. The distance set the record. The brightness broke the theory. Remember the prediction: dim, small, rare. MOMZ14 is none of those things. It is luminous, brilliant, the kind of bright that should take a galaxy hundreds of millions of years and many generations of stars to build up to. And it is not a lucky accident either. That same survey scanning a sliver of sky found that bright galaxies at this impossibly early age are not rare at all. They turn up more than 100 times more often than the models predicted. Not 20% more, not double, more than 100-fold. Picture standing at the edge of a forest at night, certain it is empty, sweeping a single flashlight across the dark, and catching 100 pairs of eyes shining back where you expected none. That is the feeling in the field right now. The early universe was not a quiet, half-empty room with a few candles guttering in the corner. It was already lit, already roaring. The lights came on far earlier and far brighter than anyone thought was physically possible in the little time the universe had to work with. With Webb, we are able to see farther than humans ever have before, Naidu said, and it looks nothing like what we predicted. One of his colleagues, a researcher named Jacob Shen, put the real problem plainly. There is, he said, a growing chasm between theory and observation in the early universe. Webb did not gently revise the old picture. It drove a truck through it. And that leaves one question standing in the wreckage, the one that turns a record into a mystery. How do you build a galaxy this fast? The first suspect everyone reached for was a black hole. Many distant bright objects shine because a feeding supermassive black hole sits at their center, pulling in gas and blasting out radiation as that gas spirals down the drain. An object like that can fake the brightness of an entire galaxy. So the team looked carefully at where the light was actually coming from. It was not a black hole. The glow was not coming from a feeding core. It was coming from stars. It was coming from an enormous number of stars, packed into a space startlingly small. We are talking about a galaxy only a few hundred light-years across, around 500 light-years, tip to tip. Our own Milky Way spreads across 100,000 light-years. MOMZ-14 takes a whole galaxy's worth of fire and crushes it down toward a single point near the dawn of time. It is the most distant galaxy ever imaged, and one of the most compact objects of its kind we have ever seen. All that light jammed into almost nothing, so the room we were told was empty is not just occupied. It is holding a furnace the size of a spark, burning like something that has been alive far longer than it actually has. 280 million years is not much time. It is easy to let that phrase slide past. So before we reach the strangest thing about this galaxy, it is worth standing there for a moment, inside that early universe, and feeling how little time that really is. If you could somehow stand at the edge of MOMZ-14 and look around, you would find yourself inside a universe that bears almost no resemblance to the one outside your window tonight. There is no familiar sky. There are no constellations, because there are barely any other galaxies to see. The few that exist are blazing, violent infants. The whole place is hot, crowded and young, a furnace of star formation running at a rate that could never last. You would be standing among the very first generation of the universe's lights, surrounded by stars so massive they would make our sun look like a single spark thrown off a campfire, and you would have no way home. Because home, the Earth, the Sun, the Milky Way as we know it, will not exist for another 9 billion years. You would be standing at the beginning, watching it begin, with everything you have ever known still waiting almost the entire age of the universe to be born. That is what a redshift of 14.44 actually means. Not a number on a chart. A place so early that the sky is nearly black, and the few things burning in it are already breaking the rules we wrote for them. And the strangest rule this galaxy breaks is not about how much light it makes, or how tightly that light is packed. It is about what the galaxy is made of. Stars are factories. They forge heavy elements in their cores, then die and scatter those elements into space. And the next generation of stars is built from the leftover ashes of the last. It is a slow process. It takes many cycles of stars being born, living and dying to load a galaxy with heavier elements. With only 280 million years on the clock, the universe simply had not had time to run many of those cycles. There should not be much heavy material around yet. The early universe was supposed to be almost pure hydrogen and helium, chemically clean, barely touched. Except MOMZ-14 is loaded with nitrogen. Strangely loaded, its ratio of nitrogen to carbon comes in higher than the Sun's. And the Sun sits in a galaxy that has had more than 13 billion years to cook. A galaxy barely alive for the blink of a cosmic eye somehow carries the chemical signature of something far more mature. That is the part that genuinely does not fit the timeline. As the Harvard astronomer Avi Loeb put it, the nitrogen we are seeing simply cannot be produced by normal stars in the time available. Normal stars cannot do it. So something abnormal had to. And this is where the story turns quietly eerie, because that nitrogen-heavy fingerprint is not new to astronomers at all. We have seen it before, not at the edge of the universe, much closer to home. We have seen that same chemistry in some of the oldest objects in our own galaxy. The globular clusters. These are tight, ancient balls of hundreds of thousands of stars that orbit the Milky Way like relics left over from the universe's earliest days. A small fraction of their stars carry the exact nitrogen-heavy fingerprint that MOMZ14 is showing us from 13.5 billion years away. The same strange chemistry at two ends of time that could not be further apart. That raises a possibility that is hard to shake. When we look at MOMZ14, we may be watching, live, the very process that built the oldest stars in our own neighbourhood, the fossils in our backyard, caught in the act of forming on the far side of the visible universe. Rohan Naidu described it almost like archaeology. We can look at the ancient stars in our own galaxy like fossils from the early universe, he said. Except now Webb sees so far that we also get to watch galaxies from that time directly. And we are finding the same features, the same unusual nitrogen. Let that connection land for a second, because it is the kind of thing you will want to tell someone tomorrow. The most ancient stars in our own galactic neighbourhood, and this impossible far-off galaxy at the edge of everything, may be the same kind of object, seen at the two opposite ends of time. But that still does not explain how the nitrogen got there in the first place. And the leading idea is also the most extreme one on the table. The best explanation astronomers have is a kind of star the universe cannot make anymore. Not the ordinary massive stars we already know, the ones 10 or 20 times the mass of our Sun. These would be true monsters. Stars potentially thousands, even tens of thousands of times the mass of the Sun. And only the early universe could have built them. Back then, the gas was nearly pure hydrogen and helium, with almost none of the heavier elements that let a gas cloud cool down and break apart into normal-sized stars. Gas that cannot cool cannot fragment. So instead of collapsing into thousands of ordinary stars, a single cloud could keep falling inward, piling up, building one colossal object. In a crowded early cluster, stars could even have collided directly, snowballing into something enormous. A star like that would burn through its entire life in a geological instant and flood its surroundings with exactly the nitrogen-heavy material we are now seeing. These supermassive stars have lived on paper for years, theorized, modeled, argued over in journals, never once confirmed. MOMZ14 might be the first place we are seeing their fingerprints written into real light from a real object. Might. The word matters, and the people doing this work are careful with it. Avi Loeb and his team are chasing exactly this idea right now. But this is the raw edge of what we understand, and the mystery is wide open. And there is still one more reading buried in that same light, one that points somewhere the models flatly forbid. When light this ancient travels toward us, it has to pass through the early universe's other fog, a cold sea of neutral hydrogen gas that filled all of space before the first stars finished burning it away. That gas leaves a mark on the light, a smear astronomers call a damping wing. At a redshift of 14.44, nearly every model we have says space should still have been almost completely full of that neutral gas, and the smear should be strong. MOMZ14's light does not show a strong smear. The gas around it appears to have been cleared already. At a moment the textbooks say it had no business being clear. The signal is faint, and the researchers are careful to call it tentative. But if it holds up, it means the universe began switching on and turning transparent earlier and in more places than anyone expected. Astronomers call that clearing reionization, the moment the cosmos burned off its own fog and became see-through. And pinning down when it happened was one of the reasons Webb was built in the first place. MOMZ14 hands them one more data point, and it is pulling the timeline earlier. One more clock running ahead of schedule. One more way this single point of light keeps insisting our story is wrong. This is what makes it so much bigger than one galaxy. MOMZ14 is not being treated as a curiosity. It is being treated as the brightest member of a whole population we did not know was there. Every time Webb pushes the horizon back, the early universe turns out busier, brighter, and faster than the time before. The record for the most distant galaxy has been broken again and again in just a few years, each champion holding the title only until the next image comes in. As the Yale astronomer Peter van Dokkum put it, that title changes every so often, but it is always cause to pause and reflect. We are not slowly confirming what we always believed. We are repeatedly discovering that we were wrong in the same direction over and over. And in science, that pattern usually means something underneath the theory has to give. Webb was built to find the first light in the universe, and it is carrying us closer to that line than we have ever been. The first stars are thought to have ignited maybe 100 million years before the moment we are seeing MOAM Z14. A few more records, a few more impossible galaxies, and the telescope may actually reach them. And it will not work alone for long. The upcoming Nancy Grace Roman Space Telescope is designed to sweep enormous patches of sky and flush out hundreds more of these early candidates for Webb to confirm one by one. The frontier that took decades to inch toward is about to open all at once. For most of human history, the beginning of everything was a story, numbers in an equation, a thing that happened so long ago and so far away, it might as well have been a myth. And now there is a machine floating in the cold 1,000,000 miles from here, walking backward through time toward the first sunrise the universe ever had, and photographing it. We went looking for an empty room at the dawn of time. We found it already full of light, already on fire, already busy becoming everything that would one day become us. The Dark Ages got their name from us, from our certainty that nothing worth seeing could be happening that early, in that much darkness, with that little time on the clock. MOAM Z14 is the universe quietly correcting the record. The lights were already on. We simply did not have the eyes to see them until now. Thanks for watching, and I'll see you in the next one.